Okay, let's give you guys some more practice. So currently we've got a plane at this location. So the plane is currently 1 across, 2 in the y direction, and then 3 in the z direction. So currently the plane is at this location. It's traveling in this direction. It's traveling in this direction at this speed. So in this direction means 1 across in the x direction, 5 across in the y direction, and then two up. So currently the plane is traveling in this direction, but the problem is that the magnitude of this is greater than the speed of the plane. The speed of the plane is only 4 meters per second. Unrealistic, but let's just pretend. So this is this magnitude here represents the speed of the plane, but then the magnitude of the vector, the magnitude of the direction is greater than the speed, but somehow work out the location of the plane after 7 seconds. Okay, so work out the location of the plane after 7 seconds. So press pause and have a go. Okay, so to do this, the problem is, hang on. So this is our direction. This is our direction, 1 across, and then 5 across in the y direction, 2 up. So this is our direction, but the plane speed is only 4. The magnitude here is only 4. So the trick here is to extract the direction from this vector. And remember that the trick, we've used this trick before in the past. We could extract the direction by dividing it by its magnitude. So to extract the direction from this magnitude, we would get the whole vector divided by its magnitude. So let's just say that the whole vector here, from here to here, let's just say the magnitude is, I don't know, let's just say 7. If this magnitude is 7, you would get the vector divided by its magnitude. Then that would then give you a unit vector. So it has a magnitude of 1. So really you having a magnitude of 1, you having a magnitude of 1 is really you extracting the direction. Once you've got your direction, then multiply it by 4. Then now this block here will really represent your speed in that given direction. So let's start again. The problem is that this vector here is bigger than our speed of 4, because from here to here represents 4, but the problem is this thing is bigger. So we would extract the direction. So we would get the vector divided by its magnitude. This thing here would represent a unit vector in that direction. But then because we want it to have a magnitude of 4, so we would times it by 4. So now this block here would represent a magnitude of 4 in that given direction. So this block here represents this. So now our equation of our straight line, the equation of our straight line is given by our starting position, plus a scalar amount. So currently this is our vector here. If you want to know the plane after 2 seconds, you would insert a 2 into this t. So that would be 1 second, 2 seconds. If you want 3 seconds, insert a 3 into that t. It would take you to here, and so on. If you stick a negative 1 in here, it tells you the plane 1 second earlier, if that even makes sense. So our equation for a straight line here is given by this. So now we need to extract the unit vector. So extracting the direction, this unit vector here is the direction. So we would get our vector here divided by its magnitude, which would be this. So our equation for a straight line is now given by this. This is our starting position, this is our speed, and this is our direction. So now we want to know the location after 7 seconds. After 7 seconds will be us putting 7 into this t. So after 7 seconds, our initial position stays the same, But then 7 times 4 here, remember 4 is a speed. 4 is a speed. So combining the two, that will then give you this. So if you want to know the precise location, so our equation for a straight line is given by this. If you want to know the precise location after 7 seconds, you would look at the x component. Look at the x component. So that would be 1 plus, well, this gets multiplied to the top. And then if you want to know the x location of the plane after 7 seconds, extract the y component. So that would be this. 2 plus, well, 28 times 5 would be this, plus this. If you want to know the z location of the plane after 7 seconds, you would extract the z component. So that would then give you this. So this here represents our location of the plane after 7 seconds. Okay.